This is Lucas. He's clearly having a nightmare. Well, come on, let's see what it's about. Ah, I see. He's scared of his math test tomorrow. Before we continue watching him suffer, let's learn something to try and help him out. This is an exponent. You hopefully already know that. Well, alright, let's start by taking a look at this table of values. This clearly doesn't represent a linear graph. We know that because the first differences are, well, all over the place. And we can also probably tell that the second differences are going to be all over the place as well, so it's not a quadratic equation either. Well, what happens when you look at the ratios of the y values instead of the differences? That's a 2, that's a 2, and that's also a 2. Look at that! There we go, there's definitely a pattern there. That's how we can spot an exponential function just based off its graph, by looking at the ratios instead of the differences. This line shown in red is an example of exponential growth, because it's an exponential function that's increasing. This line in blue, however, is an example of exponential decay, because it's an exponential function that is decreasing. Next, let's go over the exponent rules. Any number raised to the power of 0 is 1. But why? Well, another exponent rule states that any number raised to a power over the same number raised to another power is equal to, well, that number to the power of the first power minus the second power. Let's see why that works. Start by taking a to the power of 6 over a to the power of 4. We can rewrite that as a times a times a times a times a 1, 2, 3, 4, 5 times a over a times a times a times a. There we go. Well, wait a minute. We can actually cancel out 4 of these a's. So that just leaves us with a times a, which is equal to a squared. Now let's go back to the start with a to the power of 6 over a to the power of 4. Well, a to the power of 6 minus 4 is equal to a to the power of 2. Which is what we got earlier. Nice. Now, how about we try something like a to the power of 3 over a to the power of 3. You might have spotted it already, but any number divided by itself is 1. So a to the power of 3 over a to the power of 3 is 1. A to the power of 3 over a to the power of 3 can also be written as a to the power of 3 minus 3, which is equal to a to the power of 0. We already know that this, which is equal to this, is equal to 1. Nice. Another exponent rule states that a number to the power of another number times that same number to the power of another number is equal to the base, which is basically the part of the number that isn't the exponent, to the power of the two exponents added together. So a to the power of m times a to the power of n is equal to a to the power of m plus n. Let's demonstrate this by showing how it works. A to the power of 5 times a to the power of 2 can be rewritten as, let me take a deep breath for this one, a times a times a times a times a, and then we can't forget the a squared, times a times a. There we go. And since there's 7 a's in all of this, we can just rewrite this equation as a to the power of 7. Look at that. But wait a minute. If we take a to the power of 5 plus 2, we also get a to the power of 7. A to the power of 7 is equal to a to the power of 7. Nice, so we've just proven this rule. The next exponent rule we're going to go over is this one. If you take a number, raise it to a power, then raise that whole thing by another power, the result will be equal to the original base to the power of the original exponent times the other exponent. So let's take a to the power of 3 and raise all that to the power of 4. We can rewrite this as, why did I do this? A times a times a, so that's the first one, times a times a times a, that's the second one, move all this to the side, times a times a times a, third one, I'm almost done, almost free, times a times a times a. There we go, that's a pretty big number. But if you look at it carefully, you see that there's 12 a's in this. So this equation right here can be rewritten as a to the power of 12. And if you look closely, a to the power of 3 times 4 is also equal to a to the power of 12. That's pretty cool. So the next thing we're going to be going over is, whoa, I think he's waking up, but we're out of time. What are we going to do now? His test is in 2 hours. Tune in next time for more math and a conclusion to this sordid tale.